week 8, what we will do, we will discuss what is continuity. Okay, continuity. Then after that, in this portion only we will discuss about sequential criteria for the continuity criteria. Then after continuity, what we will do, we move towards differentiability. Then thirdly, we will discuss about L-Hospital rule, LH rule. Then we will go forward and we will discuss about tangent line. Then the last topic will be linear approximation. These are the 5 major topic that we will discuss today. Okay. Okay, just a minute. Let's start with limit. Okay. So what will you know about continuity? Oh, sorry, limit. So my first question is, what is limit basically? Someone please unmute themselves, and then answer. What is limit of a function?
So a limit is defined as a value of a value that a function approaches the output for a given input value.
Output for a given input value. So what you are saying basically, suppose we have a function fx and we have a point A, then according to you, if function approaching my function fx is approaching towards f of A, then we will say its limit exists at A. That's what you are saying?
Yes, sir. On every input, the value of function approaches to the output of the function. If
This
I'm
is what that you are saying, right? If
yes, sir.
x go towards A, then according to that, your fx should go towards f of A. That's what you
Yes,
want to
sir.
say?
Yes, sir.
Okay. Okay. Is there anyone else apart from that? What is limit basically? Hmm? Please answer. Okay. Even if you are wrong, I will correct you. Okay. Please answer. Then only I will understand you. You know the basic idea about limit or. Hmm? Am I audible to all right?
Yes, sir. You are audible.
Yes. If am I audible, then answer me. Or should I call by name? Okay, Radhe, tell me. What is the definition of limit? Please unmute yourself. Radhe, are you there in class? Hello. Hello. Radhe, are you there in class? Okay.
Yes, sir.
Oh, it's some. Yes. So tell
Then
me the definition of limit. What is it?
value of that fraction approach the output.
Okay. So basically, everyone is saying, sir, if you want to calculate a limit at a point A, then you have to see the functional value or at A and then see where the function will go as my axis approaches towards A, right? Okay, is there any definition that you know, guys, any one of you? And my question is whether the definition, whatever I have written here, is it correct or not?
Whatever is written is correct, sir.
It is
Uh,
correct.
when x approaches a, how is the function behaving? Is what is limit?
Okay, so we are talking about limit, right? We are not talking about continuity here. That you should remember the thing. Okay, so basically whatever thing I have written here, I have I have doubt on it. Why I have doubt? Because what is the definition of limit basically? So let's see what is limit. Okay, so before going towards this limit, we will discuss about what? We will discuss about left hand limit. Okay. Suppose your function is this. This is your coordinates and your function is this. Okay. Now this is your point. Suppose what to say. This is your point x is equals to 2. Okay. Now I need to calculate the left hand limit. Left hand limit. Limit at 2. At x is equals to 2. Now what I want to see basically since here we are using this left hand thing, it means that in the Cartesian plane, what we will do, we will go towards in the x, this line. This line is also called as real line. This line is also called as real line. Okay. And in Cartesian plane, we will say it's the x-axis and this is y-axis, right? That we have learned in the V2 only itself. Okay. Now what we will see, we have to move towards this A by left hand side. So this is our left hand side, right? So we have to move by this way. Now, how many ways that we have? Suppose there is a point, suppose there is a medical shop. Okay, this is my medical shop, and there is a path. Okay, now here is my home. This is me. Now I want to go to this medical shop. So how many ways that we have? And what is the condition? I can move either this way or this way. So how many ways that we have? And how we can go?
2 ways.
What about this path? What are the
One
property
way.
that this path have?
So you have one way to reach the medical shop.
Okay. So by this way, if I will go by this way, I can move towards this, like I can reach to this medical shop, right? Now, what are the conditions that we have? The thing is that either I can get this path. What are the path means? It means that this road, okay, this road. Either I will get a very smooth road, means that there will be no scratches or there will be no khadda kind of thing in this road, right? It will be smooth. It's just like if I will start my Bugatti, then I can directly go by 350 speed, right? That kind of
Yes,
road
sir.
I will get. This is one possibility. Another possibility that there are some spot kind of things. Suppose there is a what to say, there is a
Maybe
lava
there is a
kind of
hole.
thing. Yeah, there is a lava kind of thing in this region. Suppose there is a lava, Jwalamukhi is there. And have you seen that movie where the lava is inside and there are some small rocks and then you have to jump and go? That kind of thing. So firstly, you are there. Now you have to see that how will I go by this way. This is the possibility that you have by this path, right? Whether I can get the smooth road, it means that there will be some small cut. That doesn't matter. But yeah, you can start your Bugatti and then you will move towards, or you will say you can start your Splendor Plus and then you will go by 100 speed, and there will be no issue. The another thing that you will get, suppose there is a river and then there will be some small rock, or you can say, sir, there is a bridge which is broken by this kind of part. So first, how will you go? You have to jump in this point. Then after that, you have to jump in this point, then this point, then this point, then this point. Then you will reach towards this medical shop, right? This is the way.
Yes, sir.
So basically, how many ways for reaching this that we have? We have that either we can go in a smooth pattern. Smooth pattern means that we will start our Splendor Plus and then we will ride by 100 speed and 120 speed. I don't know it will go to 100 speed or not, because in my hometown I have a Splendor and then the speed will be stuck by 80 only. So yeah, I will just go like that. Other thing that I will go by jump like this. I will jump like this. Okay, so what is the difference between both the thing? The difference is that from here, what I am doing, I am choosing some specific point, right? So basically what I am doing, this is my 2. So what I am doing this by this jumping process. Other one is that I can go directly smoothly. Okay, no such issue in that. The other thing that what I am doing, I am choosing some points. Infinitely many points will be there. But what I am doing, basically, I am choosing some point and then I am starting a running from here. I am starting a jump. I start doing a jump. Okay, so firstly I will jump and reach here. Then I will jump and reach here. Then like this. I am jumping like this. So what I am doing basically I am choosing some points, say x1, x2, x3, x4, like this. And what are the condition in this point? Here, if I will say xn is my nth point in this line, then your xn is approaching towards 2, right?
Yes, sir.
Right?
Yes, sir.
Right? What I have done here, I have chosen some points. What kind of points is? It is like it kind of jump point, like where I will jump here, like this, and I will try to reach towards towards 2. Right? And this all the thing that I am doing, that is we are doing by left hand side only. Okay.
Okay, sir.
Understood this one? So this is what basically, this is sequence, right? Sequence of real
Yes, sir.
number. Real number, because here also I have some pre-decide places, and then where I am putting some value like x1, x2, x3, and x4 like this, right? And what is the condition of this xn? It is going towards 2, right? Now, according to that, if I will define my function fx on this whatever this reason is, and then I will see f of xn, what are the possibility that this f of xn has? As x1 goes to 2, xn goes to 2. Either this will go to some finite value, L, right? Or it will diverge to plus infinity or minus infinity. These are the 3 conditions that we have according to the definition of function, right?
Yes, sir.
Right? Now, if this function will go to some finite value, as my xn goes to 2, if this fxn, as my xn goes to 2, if my fxn will go to some finite value L for all xn, it means that I am considering all the possible sequence in here, like all the possible jump point, all the possible jump method. Okay. all the possible jump pattern. It means that firstly my x1 was like this. Now for different sequence, my first entry is this like this. Or what are the sequence that we can take from the left side of 2 that approaching towards 2? Then for that, if my fxn goes towards L, then we will say my left hand limit at x is equals to 2, left hand limit of fx at x is equals to 2 is L. Got the idea? Let's take an example. Suppose my x square is there. Fx is equals to x square is there. Now what is its function? This. Now we will discuss about what is the limit at x is equals to 1, left hand limit. Okay. What it will be? Let's see. Now take some point. Suppose I have chosen here x1 is equals to 0.5. Now what will be my fx1? 0.5 square,
Yes, sir.
right? What it will be? 0.5 square.
0.25.
0.25. Now, or we will say, let's take this we can write it as like this, so it will be 1/4, right?
Yes, sir.
Yes, sir.
Okay. So at x equals to 1, this is what? This is 1/4. Now take one more point from here. Say what? X1 is equals to 3/4. What it will be? Sorry, x2 is equals to 3/4. So what will be my f of x2? It will be
9 by
3/4
16.
whole square, which will be what?
16.
9/16. What is the value of 9 by 16?
0.56.
0.56 to 5.
0.56. Okay, take calculator with you. Okay. Now I have taken this. Now I have to take some value from here. So what it will be? What we can take between 3/4 and 1? Okay. Say x3 is equals
0.9.
to 0.7. Okay. 0.7. What about f of x3? It will be 0.7 whole square, which is what? 0.49. Okay, doesn't matter. So take x4 is equals to 0.8. Then what about our f of x4? It will be 0.8 whole square. Means that 0.64. Right? What about x5 is equals to 0.9? It will be f of x5, which is equals to 0.9 whole square, which is what?
0.81.
0.81. Right?
Yes, sir.
Now, because I am taking all the points before this one, okay, see here I have chosen 0.7 3/4. It doesn't matter, it will be increasing order or decreasing order, it doesn't matter. Okay, basically you need to choose a sequence before one and then see where this, according to this sequence, its sequence is going towards one, where the functional value will go. That's what you have to see. Okay, now let's see x6 is equals to 0.99. Can someone please calculate the value? What will be my f of x6? 0.99 whole square. What is
0.98.
0.98. Okay, let's take x7 is equals to 0.999. What it will be?
0.998.
998.
0.998. So what we are seeing here basically, what is our observation? The observation is that whenever I am approaching by this sequence I have taken arbitrary, right? This sequence xn. I don't know what is it in a term right now, but what we have observed here that we have observed that whenever my xn is going towards 1, according to that, my f of xn, which is my xn square, is going towards 1 only. Right?
Yes. Yes.
It means that now, no matter what are the sequence that we will take, but no matter what are the sequence that we will take, this thing always happen, right? You can choose arbitrary sequence. Here I have chosen one pattern. You can choose any sequence. Okay, any sequence. This thing will follow, right? Always.
Yes, sir.
So we will say our left hand limit, and that we will show like this: limit x tends to 1 minus f of x will be what? It will be this one.
1.
This is my L, right? Right? So this is known as left hand limit. Now, in the entire definition that we have explained here, does I have discussed about f of a or f of 1?
No.
No, right? It means that in the definition of left hand limit, we don't need to worry about this functional value at a point A or at a point 1, whatever it is. Right?
Okay.
What are the point? Like if we are calculating a limit at x is equals to a, it means that we don't need to worry about this x is equals to a, what will be my functional value, right?
Right.
Got the idea? So it means that what are the definition that we have seen here earlier, that as x goes to a, my fx should go to f of a. It is incorrect,
Yes, sir. It should go to
right?
some
Because
real
this
number.
is a stronger condition. Here I am saying any L. If I will get any L, then it will happen. Right?
Yes, sir.
Right? Now, similarly, you can go by right hand limit, right? Whatever thing that you have seen by this way, you can also calculate by this way. Similarly, you have to choose a sequence. That sequence is going towards this point by the right hand side, and then see where your function value f of xn is going towards L or not. So, suppose for that I am choosing L1 or not, right? Three possibility will be there, right? If my xn will go towards A by right side, okay, by right hand side, then my fxn, what will be the possibility? The possibility is that it will go towards some real number. Another possibility, it will go towards infinity. It will go towards minus infinity. But I am only interested on this. If it will be go towards L1 or not for all xn. So if this happens, then we will say right hand limit exists, and what it will be? It will be limit f of x as x goes towards a plus, which will be what? This L1. Now, here LHL is exists. Suppose now for any arbitrary function, for any arbitrary function, how many possibility will be there? If I am calculating the limits at x is equals to a, then the thing is that my f of as sorry, the thing is that there is some cases, right? Either the case one is that left hand limit and right hand limit does not exist, both does not exist at a, right? This is one case. The another case is that left hand limit exists and right hand limit does not exist. The case 3 is that right hand limit exists and left hand limit does not exist. What does it mean? Does not exist. It means that either it will go towards infinity or minus infinity. Okay. Okay, getting my point or not? What will be my case 4? The case 4 is that both RHL and LHL will exist. Right?
Yes, sir.
Okay. So what are the three cases that we have discussed earlier? This case 1, case 2, case 3. In this case, we will say limit at a point x is equals to a does not exist. If one of the one of the LHL or RHL is not exist at that point for the given function, then we will say limit at that point is not exist. Okay. Now, suppose if we have both exist, then there is suppose RHL is my L1 and LHL is my L2. Then what are the possibility that we have? Either L1 not equal to L2 or L1 equal to L2, right? Right?
Yes, sir.
Right? Now, if this happens, then also we will say limit does not exist. Does not exist. Now, if this case happens, then we will say my limit equal to L. Then we will say my limit x tends to a of fx will be my L. Okay, got the idea behind it? Okay.
Yes, sir.
Now here earlier, so this is what that we have discussed in the limit part in the earlier classes. Okay, so now just observe that here we did not mention that what will be this L. Right? Right? We did not discuss about what will be this L. What we was saying about this limit definition. If there is some L, for that this kind of thing happens, the LHL and RHL both equal to that L at some point, then we will say on that point the limit of fx will exist and it will be equal to L, right? But we don't have any specific idea about this L, right? Right? So in this
Right.
case, suppose now what are the possibility that we have for this L? What are the possibility? Either this L, because there is a possibility that the function is defined at a. Your fx is defined at a. So what are the cases that we have? The case that we have, the case 1 is that either f of a is defined, or someone will say a belongs to domain of f. And the case 2 is that it does not define DND. Don't say it is do not disturb. Okay, here our this word means does
Do
not
not
define.
define. Does not define.
Yeah. Or we will say A does not belong to domain of f. Okay. If we are calculating some limit at a point, these two possibilities that we have, either that point belongs to domain of f or it does not belongs to domain of f, right?
Yes,
Right?
sir.
Now, if let's discuss about this case too. If it is not defined, and like if function is not defined at this point A, or if we will say my A is not inside this domain F, we will not worried about it. We will only worried about it whenever this function fa is defined, or let us say this A is belongs to domain of F. Now, if A is belongs to domain of F, then what are the possibility? Either this L is equals to this f of A, or what? this f of a does not equal to L, right? These are
Yes,
the
sir.
two possibilities that we have. Either this L is equals to f of a, or this L does not equal to this f of a, right?
Right,
Now,
sir.
if the first case will happen if limit at limit of f of x at a is equals to my f of a, then we will say my function is continuous at a point A. And for that my A should be inside domain of F. Right?
Sir,
Right?
can you repeat it again, sir?
What I am saying, see, what are the limit that we will get? The possibility is that either this A belongs to domain of F or A does not belong to domain of F. If A does not belongs to domain of F, this case will happen, then we will not worried about it, forget about it. Okay. Okay.
Okay,
It's
sir.
just like suppose there there is a home where a father has two sons, the son A and B. Now, son A is what? He is a very kind person. He is very nice person. He is just like what to say? He is an ideal child. And the second person is like he is drinking and all. He is like whatever he can do, he is doing like that. Okay, so the father is like he is very worried about this person because he is not like he's
Not
not
ideal
maintaining the
person.
discipline and all, and he's very bigla kind of person. Okay, he's very
Yes,
like
sir.
he's sorry. So what he will do after that, the expectation for this person will be like all the expectation will be gone, right? He will say let's leave let's do whatever he want, let's leave it. That kind of thing is happen. If something is not inside your domain, you don't need to worry about it. Let it go.
Okay, sir.
Okay. Now we will worried about only when the something is inside your domain. Now if f is inside domain, then your f of a will be defined, right? Then f of a will be defined. Now in this case, now you know that the limit at x is equals to a is exist and which is L. Now what are the condition? Either this L will equal to this my functional value at a, or it is not equal to my functional value at at a, right?
Yes, sir.
Now if it is not equal to if it is equal to if it is equal to functional value, if the limit is equal to the functional value, then we will say my function is continuous at x equals to a. Okay. Now if this case happen, then we will say f is discontinuous. Discontinuous at x equals to. Okay, not only this case, what are the case that we have discussed? If limit does not exist, and this case also, if my domain, if A is not belongs to domain of F, then we will say function is discontinuous. Basically, what we will say, if function is not continuous at a point, sir, how to differentiate values of x? How to differentiate values of limit
Sir,
x goes
if
to
we
A?
want to check whether there is a limit for function, we'll find left hand limit and right hand limit. How to
So
find
basically,
that?
what we are doing in the left hand limit, this is my A. So for calculating left hand limit, what are the points that you have to take? You have to take the point by this way only. It means that all the point whatever you will choose in your sequence, it will be strictly less than to your A.
Yeah. less than
Okay, now for the right hand limit, what you will do? What are the point you will take it that xn will have to be greater than a, because you are taking the large value of a.
Yeah.
What the idea?
So, can you take a small example, like how to find right hand limit and left hand limit?
Okay, let's take. Suppose you have fx which is defined. This I will explain by a continuity as well. Okay, this is my x square and x is greater than or equal to 0, x and 1 cannot. One as x is equals to 0. Now, how will this function look like? It was initially as x, okay, then it will be x square, x as x goes to 0, and here value is not exist, and the value at x equals to 0 is what? 1. This is my motor function will group like look like, right? This is my graph of the function that we have given above, right?
Yes, sir.
Now take a sequence which is going towards this. Suppose I have taken arbitrary sequence xn which is going towards 0 with the minus side. It means that if left side, this minus is denoted that we are approaching towards 0 by the left side. What will be my f of xn? My f of xn is what? If I will take any value which is less than 0, it will be defined by this x only. Right? So f of xn is what? My xn only.
Yes, sir.
Right? Now xn goes to 0 minus, means that left side towards 0, then my this xn, this f of xn, that is my xn only, this will go towards 0 only, right?
Yes, sir.
Yes, sir.
Right? So what will be my left hand limit at x is equals to 0? It will be 0 only.
Yes, sir.
Right?
So the sign of fx, the sign of xn is sir negative, na sir, because
Yeah.
when
Here,
we
what
put
are the
any,
xn you are taking? The xn is less than 0. Doesn't matter now. I have taken arbitrary xn which is belongs to R, and this happens. That's it.
okay, sir.
You don't need to take a minus sign here because you don't know about this xn whether it is positive or negative.
Okay, sir.
Okay. Now, what about the right hand side? Take yn which is going by this way towards 0. So if you will take such yn, it will be greater than 0 always.
Yes, sir.
And here yn going towards 0 plus, it means that yn going towards 0 with the right hand side. This positive direction, you can say. Now, what will be my right hand limit at x is equals to 0 plus 0? It will be, now what will be my f of yn basically? It will be yn square only.
Yes, sir.
Right, according to this function, because all the x, whenever x is strictly greater than 0, it will be x square. Now what it will be? What will be my right hand limit? The right hand limit will be 0 only,
Yes, sir.
because if yn goes towards 0, this yn square will go towards 0 only.
Or add 0, it becomes 0.
Sorry,
So add 0, it becomes 0.
no, because at 0 we have defined it is 1.
Right.
Okay, sir.
At 0 we have defined it is 1. So what is the observation? Limit as x goes towards 0 of fx, which is 0, because my LHL and RHL both are equal. Right? Also, this 0 belongs to my domain because we have defined this 0. And what is the condition that we have? The condition that we have is this is not equal to my f of 0, which is 1. Right?
Right,
And we
sir.
can
Please, sir,
left
please
hand limit
repeat
and
it.
right hand limit exists, but the function is not continuous.
Yes. So basically what happens here, according to this definition that we have seen that the left hand limit at 0 is 0, the right hand limit at 0 is 0. And since both are 0, 0, it means that left hand limit and right hand limit both are equal. It means that the limit of fx at x is equals to 0 is exists. Okay, is exists. And which is not equal to my functional value f of 0. Because f of 0 is what? It is 1. Then we will say limit exists at x is equals to 0, but function f is not continuous at x is equals to 0. Got the idea? Got it? Why it is not continuous? Because limit does exist, but it is not equal to the functional value. Okay. Now, if I will slightly change my function, same function, if I will change my gx is equals to like this, same function is there, x square x, and then I am changing this 1 as 0. Greater than 0, x is less than 0, and x is equals to 0. Then in this case, limit exists, LHL equal to RHL. What will be my f of 0? My f of 0 is 0 only, which is 0. The limit x tends to 0 of f of x, which is equal to 0, which is equals to f of 0, then we will say f is continuous. This is a different function. This is a different function. Okay. For this function, for this function, it is continuous at 0. For this function, it is not continuous at 0. And what is the reason that I have explained here? Okay, got the idea of continuity and all?
Yes, sir.
Yes, sir.
Okay. Now, similar definition, similarly, you can directly check. Okay, just a minute. Okay, give me a second. Okay. Now, this is one of the definition that we have seen earlier and that we have seen now. Now, how many times? Like similarly, that as we have seen. Now I am changing a definition a bit change. Okay. Now I am trying to go by sequential manner. Okay. Again, continuity. Continuity. By sequence. Sequential, right? Sequential. Similar thing is here. Now, here I am discussing about this f of a, okay? Suppose this is my function. Now here is my a and I need to calculate this. whether this function is continuous at fa or not. As we can see earlier, for limit what we are seeing, we were discussing about this discrete point and we were approaching towards xn like this. Similar thing that we can say. Now, apart from this L, if I will use this f of a, then what I will say? Then we will say here like earlier I was approaching towards this left hand side and towards right hand side only, right? In this case, I will say you can take arbitrary sequence which is approaching towards a arbitrary sequence. It means that either you will directly jump here, then go like this, like this, like this, like this. Okay. What I mean to say? I mean to say that for fx is equals to x square case, take xn like this, minus 1 raised to the power n divided by n. Okay. In this case, what will happen? This is my 0. Then firstly, it was what? Minus 1. Then it will be 1 by 2. 1 by 2. Then it will be minus 1 by 3. It will be 1 by 4. Minus 1 by 5. 1 by 6. Like that. So basically how this function is going? This is starting like this sequence. Right? This is also n sequence which is going towards 0, right? Right? Please answer.
Yes, sir.
Right? Okay. What it will be? What is my f of xn? It will be minus 1 raised to the power n divided by n whole raised to the power 2.
Yes, sir.
Now what it will be? It will be minus 1 raised to the power 2n divided by n square.
Yes, sir.
What can I write it as? It will be minus this whole raised to the power n divided by n square. Now this is what? Minus 1 square is 1 only. So this is what? 1 raised to the power n, which is 1 by n square. And this is approaching towards 0 as n goes to infinity.
Yes, sir.
Right? It means that if this xn is going towards 0 as n goes to infinity, my f of xn is going towards 0. And this is what? This 0 is nothing but this is my f of 0 only. Right? Right?
Yes,
for
sir.
this sequence, it is true. So we will say here, if for any sequence, if for any sequence xn going towards a, which is belongs to my domain of f, if my f of xn is going towards f of a, then we will say f is continuous at x is equals to a. Okay, this is the second definition that we got now. Okay, first one is if the limit is equal to the functional value. The another one is for any xn belongs to a, xn goes towards a. If this f of xn is going towards f of a, then we will say function is continuous. Got the idea about continuity, everyone?
So,
So, sir, I'm a bit confused. So the previous one and this one, we are saying that over there, over here, we are following some sequence. Over there also we were following one sequence, right?
No, over there, for the sequence that we are following for the observing what will be my limit. Okay. Once we got limit, we were not worried about that. So basically there, whatever sequence that we have followed, that was whenever I was discussing about limit. Once you got limit, you have to see whether what will be my functional value. Here, what is the difference? The difference is that directly I am following this sequence, and then we are saying as xn goes towards a, I am not talking about any L and all. Here I am just talking about whenever xn is going towards a, my fxn will go to my functional value or not. Here I am not introducing any limit concept. Here I am directly showing by this xn sequence. Okay, earlier we were say if the limit is equal to my functional value. This
Right.
was my earlier value, and sequence whatever we have used earlier, that used for getting the limit. Okay, here what I am saying, that the xn, if any sequence will go towards a, okay, if my corresponding f of xn will go towards f of a, here I am not introducing any limit L. I am directly saying if it is approaching towards f of a, then we will say function is continuous. This is the another definition.
Okay. Got it.
Okay. Okay, let me see what will be further. Continuity of a function is done. Okay, let's take one more example. See f of x is equals to mod x. Okay. What about x is equals to 0, whether this function is continuous or not? 1 minute you have, just check and then let me know. It's an absolute value function. F of x is equals to mod x. How will it be
So
defined?
it's not continuous.
It is continuous, sir.
Greater than or equal to 0 minus x less than 0.
It is continuous.
It is continuous. Okay. Someone
Because the
was saying it is not continuous. Why it is not continuous?
Because when there is a positive value, then is when there is a negative value, then it decreases, and at 1 it make a sharp edge, and then when it got positive value, then it increases, then there is a sharp edge at x equals to 0. So that's why it's not increasing.
We are talking about
No,
continuity.
but continuity means that it is connected at all the points, right? So as it goes down, the graph is like V, right? So it is all connected. You don't have to lift your pen while drawing it. So it is continuous.
But I think there is
But
a
it don't look like
edge.
this. Let's go to by the definition point by point. Okay, what will be my LHL in this case? Well, the graph will be look like this. I think everyone is agreed.
Yes, sir.
The graph will look like this. It will look like this, right? This is my minus x, y is equals to minus x. This is my y is equals to x. Both will meet at 0, right? Right?
Yes, sir.
So what will be my LHL? It is 0 at x equals to 0, right? Whenever I am
Yes.
approaching towards this will going towards 0, right? Functional value.
Yes, sir.
Yes.
So what will be my LHL? It will be 0. What about my RHL? Whenever I will approach like this, my functional value will decrease and it will try to become 0. So it will be also 0.
Yes, sir.
It means that limit exists. Limit at x tends to 0, f of x, which is 0. Now, what is my f of 0? This definition. Here, when x is equals to 0, it is defined at x. So it will be 0 only. Okay? Put x is equals to 0 here. Right?
Yes, sir.
So what it will be 0 only. It means that this is equal to f of 0. Now, according to the definition of the continuous, it is continuous at 0. Okay.
Yes, sir.
See here in the continuity, we did not mention about any increasing net, decreasing net, whatever it is. I don't know about it. We were just only discussed that whether for that point, if I am approaching somewhere, that approaching point is equal to my functional value or not. If it is equal to functional value, then I am done. No need to see whether it has sharp edge and all, whatever it has. We are not worried about it. Okay, we have to just see that whether I am able to make my graph without lifting my pen or not. Thus, it is not an appropriate definition, but yeah, that's the idea. Whether I am able to see that, yeah, my functional value equal to my existing limit or not. If it is equal to the existing limit, then we will say it is continuous. No matter how function is defined.
But sir, it's not a smooth graph. Means when
Why it's not
when
a
we
smooth
draw,
graph? You are able to draw a graph, right? Where, thus we have discussed about any smoothness here. What does it mean by smoothness? First of all,
means when we draw a graph, then at x equals to 0, then we need to stop for a second. Then we go for x equals to positive direction.
why we
So
need to stop for a second? We can directly make this, no? What does it mean by stopping a graph? It means that you are pausing like this and then you are going like this. Firstly, you was increasing. Then stop means at some point your speed is 0. Then you are starting like this. Here, thus the speed is 0.
no, sir.
We are not able to calculate the speed here. That's the point.
Okay, sir.
It does not mean that we are not able to make a graph like this. We are not able to see that whether it is continuous or not. Whatever you are saying, it's a matter of speed, whether I am able to calculate the speed at that point or not. That we will discuss further. Okay. It going 0. Here I am able to calculate the speed, but it is 0. Why? Because firstly I was increasing. Then I pause and then I started decreasing. Right?
Yes, sir. I got it.
What next?
Sir,
Okay. Yes.
sir, how do we define a function value is undefined at a particular point in graph?
If it is going towards infinity or if it is going towards minus infinity. Suppose fx is equals to 1 by x. What about x is equals to 0? Not
Undefined.
defined, right? But you
Or
can define this function like this. X dot equal to 0. And then you can say x equals 0 when x is equals to 0. You can also define like that. But yeah, initially whatever I have given here for this function is not defined, right?
yeah.
What about this? Looking like step. Okay, suppose these are integers. This is your 1, this is your 2, this is your 3.
Sir, floor or ceiling?
Not floor or ceiling. It's a fraction point function.
Fraction point.
Yes. Is it? No. It's floor function, I guess.
Yeah, floor for.
Floor function. Okay. Whatever it is, but this is a function. Okay.
Right.
This is your function. It is -1. I am not defining it. What is it? Because others who are not coming from a math background, they will confuse what is floor and what is ceiling.
Can
Okay,
you
we
give
are
an
not
example?
discussing it.
Can you give
This
an
is an
example
example.
of
Sorry.
above second definitions of continuity?
For second definition. In this
Yes.
example also that we can see this mod x case. Let's take any sequence 1 by n. 1 by n, it is greater than 0. I have taken arbitrary. See, here I have choose only one sequence. Okay. but you have to see every sequence which is converging towards zero. So take any arbitrary xn which is greater than zero, because I can define like this only, na, for greater than zero, for less than zero only. So if xn is greater than zero, it is defined at xn only, and if xn goes towards zero, this will go towards zero, right? So you have seen for any sequence which is positive value, or you can take any arbitrary sequence, not to worried about positive or negative value. Any xn value, if you will see, this xn value will move like this now. If you will take any arbitrary value, either this will go like directly this, or this will be moved like this. They will start initially from here like this, and they will try to approaching zero. Okay. No matter what are the functional, what are the actual, original domain values, what are the sequential value xn is, your fxn always be like xn or minus xn, right? According to whether xn is greater than or equal to zero or less than or equal to zero. It will be like this only. So whatever it is, but as xn will go to zero, xn will go to zero and minus xn will go to zero simultaneously. It means that your f of xn will go to zero, right?
Yes, okay. Like, can you give one more example on first definition?
See,
If we take
the thing
f
is
of x
that
equals to
showing
x
by a
also,
sequential thing, it's difficult task. Okay, but why we will use the definition whenever I want to disprove that this function is not continuous. In this example, say suppose you have fx is equals to this 1 as x greater than or equal to 0 minus 1 at x less than 0. Without showing the limit, if I want to see that whether this function is continuous or not, how will I say? I will take a sequence xn which is greater than 0. Okay, in this case, my f of xn as how this function will look like. This function is minus 1 and then 1. This is my function, right?
Yes.
Right? So f of xn when xn is greater than 0, I have taken a sequence. It is also going towards 0, but it is greater. I am taking all the sequence which is greater than 0. So in this case, what we will get? I will get 1 only.
1.
It means that
Yes.
as xn goes towards 0, my f of xn is going towards what? 1, which is my f of 1.
Yes.
Now, if I will take xn which is less than 0, any sequence which is less than 0, my f of xn will be what? Minus 1. Mean that this is not equal to f of 1 for any xn. For all xn which is less than 0. Right? Means that as xn goes towards 0, my f of xn will not, my f of xn will not going towards f of 1. Not continuous. For
Yes,
instance,
okay.
you can take xn is equals to minus 1 by n. In this case, f of minus 1 by n is always minus 1, right? So as n goes to infinity, my minus 1 by n will go towards 0. And in this case, minus f of minus 1 by n will go towards minus 1, which is not equal to f of 0, equal to 1, right? It means
Yes.
that f is not continuous at x equals to 1. Right? Here we did not use any sequence, any limit criteria. Here we have directly seen by this xn thing, sequential thing, right? So sequential thing you can use only for whenever you have to disprove whether this function is continuous at a point or not. If you want to disprove it, you just use the sequential thing, because in this case you need to find a sequence for which this kind of thing happen. It means that the sequence is going towards a, but f of xn is not going towards f of a, right? You just
Okay.
need to find a sequence for that this thing happen. In this case, minus 1 by n is there. You can find infinitely many, but yeah, this is one of the sequence that is following this kind of thing. So this is
And
not continuous at all.
when can we use our first definition?
When you have to prove this is a sequence, this is continuous at a point or not.
Okay.
Okay.
Yes, okay.
Okay. In the most probably in the in the Sunday's lecture, just who will be take just say ki just ask them to solve that kind of question. How will I say whether function is continuous or not? Okay. Just
Yes, okay.
say take some example and then try to solve.
Yes, okay.
It will be more clear for you. Okay, let's move toward differentiability. This is what that continuity. How many of you guys have started watching the videos? It is released by today only. Today 12, right?
Yes, sir.
Okay. So what you guys will do between this Wednesday and Friday? Because you have submit your assignment out at Wednesday only, right?
I think week 8 assignment, week 8 lectures are released.
Okay. So how many of you have watched that? At least one of that.
Sir, I have watched 1 out of 3.
Okay, so let's discuss about differentiability. Okay, suppose let's take an example that that example is also given in the lecture as well. Suppose I am a truck driver. Okay, I'm not a mathematics teacher. I am a truck driver. Okay, and I started my driving truck. Okay, how will I? This is me, and I am a truck driver. I am very happy, and I am saying I am a truck driver. Okay. Now I started my truck and I want to go from Jaipur to Chennai. Okay, I want to go from Jaipur to Chennai. This is my agenda. Now, since I am going by road, I cannot go, reach my destination only for in 1 day or only 12 hours, right? Right? I need some time.
Yes.
It will take most probably if I will go by whatever, how much speed I can get, whatever speed I can get. What I will say, I will say I cannot reach in 1 day. So for that, I have to sleep at mid of the, suppose I am going Jaipur to Chennai. Now, first day I will cover Jaipur to say Nagpur, and then I will sleep at Nagpur for 1 day, and then I will start journey from Nagpur to Hyderabad. Then I will sleep at Hyderabad. Then I will start my journey from Hyderabad to Chennai, and I will complete my journey in 3 days. Right. Now, in this case, I need to discuss about my speed. What will be my speed in this time period? What will be the appropriate way to calculate the speed? So basically, how we will calculate the speed?
Distance by time.
Whatever distance I have covered divided by whatever, how much time I have taken time, right? 3 days. How many hours? 72. Huh? 48. 72 hours, right?
Yes.
Yes, sir.
How much distance? Suppose the distance is like what to say, 3000 kilometers. Okay, it means that I have covered 3000 kilometers. It is not exact data. Okay, I'm just expecting that much will be. So I have covered 3000 kilometers in 72 hours. Whether this way is appropriate to calculate my speed because I have slept for suppose 5 to 6 hours in 2 days. So I have wasted my 12 hours. Suppose approximately I have wasted this, right? I did not go anywhere in this 12 hours. I was stopped. My speed was 0, right? In this 12 hours because I was sleeping. So whether this way of calculating this speed is appropriate to check what is my speed?
No, sir.
No, right? Why? Because at some point I was not doing anything. I was just sleeping.
Yes, sir.
Okay. So this will affect my speed, right? That 12 hours will affect my speed. So what I will do? What is my appropriate? What is my way? How will I calculate my speed? No. So what I can do? I will choose some time period. I will choose some arbitrary small time period. And then I will see in that time period what will be my speed. Suppose I have chosen this time period. Okay. So if this is my time graph and this is my distance graph. This is my distance as suppose. Now I will choose this time period. This is my T2. This is my T1. So time period is what? T2 minus T1. Right? And then I will say, so there is a relation between this S and this T. It means the distance and time. So suppose that relation given by this function f of t, S is equals to f of t. Then I will see in that time period how much distance I have covered. Right? And according to that how much time I have taken. Right? Right? This is not distance covered by time taken in this time period.
Yes, sir.
Yes, sir.
So this will be my more accurate way. Accurate way to calculate the speed, right?
Yes, sir.
Right? This is my more accurate way. Now, what I am saying that yeah, you don't need to do this kind of thing. Now, now if I suppose if I will take this interval, this whatever time interval I have chosen, if I want to take this interval, say this is my delta t. Okay. If I want to take this is very small, it's just fraction of second, then it means that either this T1 will go towards T2 and T2 will go towards 0. It means that I need to take this delta T is very small. It means that the delta of T will go towards 0. Okay. Then in this case, I can, when my delta T will go towards 0, in this case, I can calculate my instant speed, right? At that point, instant into what is my instant speed? Have you seen that speedometer or not? How many of you guys has ride bikes or bike or scooty or four-wheeler, whatever it is? How many
Me,
of
sir.
you have ride? Okay. Most of the time, like everyone has seen, at least everyone have sit on the bike or scooty, whatever it is, at least once in a time, or auto. So have you seen that meter or not? Either it will be digital or it will be analog. So there will be a meter which will be measure our speed, right? Here 10, 20, 30, 50, that kind of thing.
Yes, sir.
So according to this speed, the analog will be, suppose I am moving by 30 kilometer per hour, then 50 kilometer per hour. What is it? Basically? It is my instant speed. What is my instant speed? Okay, it means that in that particular time, what is my speed? Getting my idea? So this is calculating by this kind of thing. This is the one of the example of our differentiability thing. Okay.
Okay, sir.
Okay, this is one of the example. Now we will relate this all the thing for differentiability kind of thing. Now, what we will say. Now here, according to this example, as delta t goes towards 0, it means that my T2 minus T1 will go towards 0. It means that my T2 is trying to become my T1, right?
Yes.
Right?
Yes, sir.
Now, what is this basically? What we are calculating, my T2 is going towards T1 and we are calculating this limit. Right? We are calculating this limit. Okay? Now replace this T2 as X, then what you will get? You will get limit X goes towards T1 f of X minus T1, f of T1 divided by X minus T1. Now, how many conditions that we have for this limit? It is exist or not exist, right? Right?
Yes, sir.
See, here also we are calculating the limit. The limit that we are calculating because I need to see what is the changes that happens in my graph. This is my graph, no? Graph of the function. What kind of changes happens at a point? If I will move this point to certain point, what kind of change it will be? Like it will be instantly up, it will be instantly down, it will be go very smoothly kind of thing. Right?
Right, sir.
Right? So basically this thing is known as what? If this is exist, if this will exist, then we will say f is differentiable at a point T1. Okay, you can say this T1 as A. You can treat as like this at point A. So what is the definition of differentiability? The definition of differentiability is saying f is said to be differentiable at x is equals to A belongs to domain of if the following limit is exist. Means that what is my following limit? Limit x goes towards A, f of x minus f of A divided by x minus A. If this is exist, then we will say a function is differentiable. Okay. And if it is exist, then we will take this will be some L. This L is denoted by f prime A. Okay. Got the idea?
Yes, sir.
Okay, everyone. What is this differentiability mean? At some point,
The function is continuous at that point.
that we will see. That we will see. Here I am not using continuity, right? Here I am just saying when we will say function is differentiable at a point or not, or why we are introducing this kind of thing. Both the idea you have understood.
Yes, sir.
Now, since here I am calculating this limit, it means that there will be some left hand limit, there will be some right hand limit, right?
Yes, sir.
Now, this left hand limit for the differentiability case, we will say left hand derivative. And this right hand limit in the differentiability, we will say right hand derivative.
Right hand derivative.
Okay, if both derivative, left hand derivative and right hand derivative are equal to each other, then we will say function is differentiable. And we will say f is differentiable at x. Okay, everyone who is not from math background, they understood or not? If you have some doubt, please ask.
So for linear
Alright.
function, the differentiation is same as the slope.
That we will see. Up to this, any doubt in the definition?
No,
If you
sir.
have, then please ask. That we will see whatever we are saying for tangent and all.
So, I want to ask you that, but what is the need to calculate the differentiability?
Okay. So that we have seen here now. Here I am not happy with that. This average speed. I am not happy with that. This average speed. Why? Because at some point I was in rest position. Right? At some point my speed was 0.
Yes, sir.
Right? So at that point,
Yes, sir.
I was not doing anything. If suppose I am an entrepreneur or I have a company and the company is that I have some drivers and all and they are like this, they are charging according to that how much distance, like how much speed it like how much speed I will at how much speed I will cover the distance, I will charge like that. Okay, so at that point, if they are saying, sir, I am approaching, and if they will charge me by this speed 0, how much I will say? Okay, suppose I have some drivers. I'm started a company and I have some drivers. Okay, and they are they every day is and I am paying to that driver by day basis. Okay, or one day suppose I am giving them money 300 rupees per day. Now, what is my motive is? My motive is take my truck, drive it from Jaipur to Chennai. This is 300 per day basis, but at my point of view, what they have done, they have sleep at for 12 hours, right? But I am
Yes,
giving
sir.
them money for extra 12 hours. For that, they did not done anything.
Yes, sir.
That I don't want because I am a very just kind of person. I don't want to lose my one single rupees. So how will I calculate? So I have to remove this 12 hour from that now. So what I will do?
Yes.
I will check their instant speed and then according to that I will check at how much time they have covered the distance. Right? Day basis, it means that per day has 24 hours. Okay. Then I will see how much time. Suppose they have covered by 48 hours. So I need to pay only 600. I don't need to pay 900 rupees for 3 days.
Yes, sir. Okay.
Understood the idea? That is why I need to calculate the instant speed. According to that instant speed, I can calculate. Suppose my instant speed is 40 kilometers per hour. This is my instant speed at any point. Okay. Now, further, we will see that instant speed is also given by some function f of x known as f prime x. This is some function. Okay. This is some function. So at any point x is equals to a, I can directly put the value x is equals to a here, and then I will calculate the value. Okay. So according to this function, I will calculate the distance easily. Right, because from that I will get the instant speed. Once I got the instant speed, I will calculate the distance, and then according to that distance I will calculate the time, how much time they have taken to cover that much distance. So, and according to that time, I will pay you. I will pay them.
Okay, sir. So for
Okay.
that, you have to make first graph so that you can do it
No need to
much
make the
better.
graph. No need to make the graph. According to that, I will got my function. No. Further, you will learn how will you get the function and all. There are some basic rules for getting differentiability kind of thing. There was some great mathematician. They have already calculated this kind of thing for me and for you as well.
Okay, sir.
Okay. Now suppose you have a function fx is equals to x square. Now you have to calculate the differentiability. Okay. Again, since I am going towards this x and this x can be anything, right? This is my a. This x either go by this way, either go by this way, right?
Yes, sir.
So let's define this left-hand derivative. Suppose h is greater than 0. Then what will be my left-hand 0? The left-hand derivative, it will be. Now, if I will
fx.
take any x which is less than a, means that if I can take this now. What? A minus h.
Yes, sir.
Right?
And when
Because
x
h
is
is greater
greater
than
than
0.
a, huh? Yes,
Yeah,
sir.
because x is less than a, it means that this x can be a minus some positive value h. So what will be my left hand derivative in this case? It will be limit. Here h will go to 0 because here I was taking x goes towards a. Now x is what? A minus h go towards
Minus
a. It means that h go towards 0.
0.
We will say 0,
Yes.
not 0, a. Yeah, 0. Okay, 0. Now we will say it is 0 minus because we are approaching from the left hand side. And
Left
this
hand
is
limit.
what?
Yes.
Yeah. Not a minus h minus f of a divided by h. Because here what? X minus a, what it will be? A minus h minus what? A. Cancel out, you will get
cancel
minus h. So
minus
here it
h.
will be minus. Here it will be minus. Okay. So what it will be basically? Limit h goes to 0. F of a minus f of a minus h divided by h. Okay. Similarly, what will be my right hand limit? For right hand limit, if h is goes greater than 0 and x is also greater than a, then we will say this x is nothing but a plus h. That we can say, right? I will add some positive value in this a. According to that, I will say. Now, what will be my RHD? It will be limit. Again, h going towards 0. Since I am approaching from positive direction, I will say, yeah, it's going towards 0 plus right hand direction. And it will be f a plus h minus f of a divided by what? H. Because it will be x minus a. So it will be a plus h minus a, which is be h only. Right? So this is my right hand limit. Now I have an example fx is equals to x square. I need to see at x is equals to a, at x is equals to 1, the left hand derivative and right hand derivative both are equal or not. It means that function is differentiable. If it's differentiable at x equals to a or not. How will I check? Firstly, I will check the left hand derivative. What it will be? F of 1 plus
1
h minus
Sir,
f of
left hand
1.
derivative है ना?
So yeah, left hand derivative.
1
So
minus h. ये 1 minus h.
is f1 minus h, not this.
F of
F1
1
minus f1 minus h divided by h. Limit h goes to 0. What it will be? It will be 1 only, minus 1 minus h square, because this is defined. This is h 1 minus. Okay. I cannot put directly h is equals to 0 because here we have denominator as 0, right? So open this in. What it will be? 1 square plus h square minus 2h divided by h. 1 minus, it will be minus 1 minus h square plus 2h divided by h. Now take h common and then cancel it out. What you will get? You will get
Sir,
2 minus h. And you need to calculate limit h tends to 0 every time. Limit h tends to 0. Here also limit h tends to 0. What you will get? You will get 2. Your left hand limit is 2. Similarly, calculate for right hand limit. Similarly, calculate right hand limit. Fast. Do. This is right. This will be 1 plus h whole square minus 1 divided by h. Limit h tends to 0. Limit h tends to 0 will be what? 1 plus h square plus 2h minus 1 divided by h. This will be also what? Limit h tends to 0. It will be h plus 2. Now it will be what? 2. Then what we have seen here, right hand derivative and left hand derivative both are same. Here left hand derivative and right hand derivative both are same, and which is 2. This means that f is differentiable at x equals to 1 and the derivative at 1, which is what? 2. Got it? How I have write here, because earlier I have explained the thing that this thing, if the limit is exist equal to L, we will write it as f prime e. Okay.
How did you get 2, sir?
Sorry.
When we substitute the value of h equals to 0, h tends to 0.
Yes.
How do we get h L2 minus h?
Minus h. Where? Here.
Yes.
So here what you have? You have here from here, since 1 and 1 both are cancelled. What is this? H square plus 2h by h.
Yes.
Now take h common and then cancel it by denominator. What you will, sorry, plus.
Okay.
What you will get? 2 minus h only, no?
Yeah.
Similarly here that we have. So for this case, what will be my what will be my derivative at 1? It will be 2, right? You know how to calculate this? Okay, let's take one more example. Fx is equals to mod x. Mod x, which is defined like this. Same example. Okay. Let's discuss about left hand derivative. Can someone quickly solve this for me? It will be what? Limit h tends to 0. F of at 0 we are trying. Okay. F of 0 minus h, not 0 minus h.
F of 0 minus. Oh,
Yes.
0 minus
Divided by h. What it will be? F of 0 is what? F of 0 is 0 only. Minus f of minus h. Here h is my positive. It means that minus h is what? This is h divided by h. Okay, limit h goes to 0. Limit h goes to 0. F of minus h is what? Here, since I am taking h is positive, it means that minus h is negative. This means that what are the quantity here has written here, it will be negative, right? So minus h can be denoted by what? H only, right?
Why is h greater than 0, sir?
That we are taking from the definition itself. Here always I was taking h is equals to greater than, because from this value, if x is less than a, if I will subtract some positive value from a, I will get this s, right? X.
Okay, got it.
This is my suppose 2. Here I have to calculate a is equals to 2. Now I am starting from 1. This is my x, and I am moving according to that. So what will be my value of h? It will be 1 only, right? A 2 minus 1 is 1. Then I will take this 1 by 2. For this case, what will be my h? 1 by 2. You're getting my point? What I'm trying to say? 3 by 2. So basically, for any x that we can take from this interval, I can get an h, positive h. For that, if I will subtract this h from this a, I will get this h, a. Because I don't need to introduce two unknown variables. I just need to introduce only one unknown variable, that is my x only. So it will be help me to solve what are the thing that we have, like for the questions, from the questions. Okay.
Okay.
Okay, so what will be my f of minus h? Since h is positive, minus h is negative, right? So it will be minus of minus h, right? What will be my f of minus h? It will be minus of minus h. Why? Because if x is negative, what I will take? Minus of that x, and here x is what? Minus h. Right? So it will be my positive h. So here I am taking positive, and this minus is coming from earlier only. So this is h by h. This will cancel out. What I will get? I will get minus. Got it? Got it? Please say something.
Yes, sir.
Okay. What about my RHD? Limit h goes to 0. F of 0 plus h plus f of, sorry. Minus f of 0 divided by h. This will be f of h minus f of 0 is 0 divided by h. Limit h goes to 0. Now, what is my f of h? F of h, where h is greater than 0, it is defining from h only. So it will be h by h. Limit h. Here, RHD is 1, LHD is minus 1. So LHD is not equal to RHD, right? Minus 1 not equal to 1. Means that f is not differentiable at x is equals to 0. Got the idea? How will I check whether the function is differentiable or not? Got it?
Got the idea, sir, but I think I would have to review this calculation, how you're doing all this calculation once again. But
Yeah.
I think overall idea I got.
Okay. Now let's move. And there is one theorem. The theorem is saying that if my function f is differentiable at x is equals to a, then f is continuous at x is equals to a. Okay, if function is differentiable at a point a, then function is continuous at a point a. Let's prove it. Suppose that function is differentiable. Means that limit f of x minus f of a divided by x minus a. This is exist and it equal to some L, right? right?
But that is for limit, no, sir. For differentiable, we
I am saying differentiable, no? Differentiable, it means that this quantity as x goes to a, it will exist, right? This is what differentiable. This is what? Change in function divided by change in input. This is the rate of change, right? Or instant speed, you can say.
Yeah.
That
Yeah.
f of t2 minus f of t1 divided by t2 minus t1.
Right.
Limit t2 goes to t1. This is what that we have seen. If function is differentiable, then this
Right.
limit should exist.
Yeah.
Right?
Right.
Earlier we have seen this definition. Now that's what we are
Right.
saying doing
Yes.
here,
Yes.
right?
Yes. Yes.
Okay. So this limit should exist. Okay. So what we can do from here? Here we can say limit x goes towards a, f of x minus f of a. I am just taking this denominator to this side. It will be what? Limit x goes to a, L time x minus a. That we can differentiate this limit in the upper direction and lower direction both. In denominator and numerator both sides, right? Here in denominator part also x is going towards a, and denominator also x is going towards a, right?
Yes.
What we can see? Limit x going towards a, f of x minus f of a, L times, because this is constant value, this will be move forward. If x goes towards a, this will become 0, right?
A minus a. 0.
Right? It will become
Yes.
0. So this will be my 0. So what I got from here? Because this a is constant, this limit will not work here. This limit will work only here, right? So what I will get? Limit x tends to a, f of x is equals to what? F of a. And this is the definition of continuity. Right? This is the definition of continuity. If x going towards a, then my limit at that point will be equal to the functional value at that point. Got it?
Yes, sir.
Okay. So this is one small theorem and its proof. And then what next? Okay, what will be my derivative function? So here there is one definition, nice definition of derivative function. Nothing is there. Derivative function. So derivative function is nothing but here earlier we were calculating at a point only, right? At a only. Differentiability we were calculating at a point. Here, as you can see here, we were calculating at 0. Earlier we were calculating at a1. So we were calculating at a point, right? If we will say, suppose my function f is defined from D to R. D is my domain and R. Okay. And there is some set, say D prime, where function is differentiable. Okay. Because we cannot say this function is differentiable at every point in this D. Right? Right? Say something. Right? Here function is defined from some domain to R, and I am saying there is a subset of this domain D where function is differentiable, because we cannot say function is differentiable in entire domain. As we can see here, this mod x example, x is not differentiable at 0. But apart from that, at any point this is differentiable. So I will remove that 0 from the domain. What? So for this f of x is equals to mod x case, what I will say, if the domain will be d dash will be my r minus 0. Because I am excluding that point where function is not differentiable. Okay. So what I am saying here. So derivative function is basically if my function is defined from d to d to r, so there will be some domain d prime where function is differentiable, and at that case the derivative function, in that case see, formal definition you can find in the book itself. Derivative function is denoted by f prime x and defined by f prime x is equals to, also we will say it is df by dx equal to limit h goes to 0, f of x plus h minus f of x divided by h. Here h belongs to r. Okay, h can be anything. H, either h will be 0 or h will be negative. It can be anything. Okay. Why we can take anything? Because from here, I have from earlier we have taken h as positive, and firstly we were subtracting it and then we were adding it. That kind of thing that we have done. Now, if I will take h for any real number, so no matter you will subtract or add, you will get this h from, right? If your h is less than 0, it means that it will be some minus sign. Suppose h is equals to some minus r, where r is greater than 0. So here, if you will put minus r here, you will get same thing. Fx minus r minus f of x divided by minus r. You will get same thing. F of x minus r divided by this r, and you are calculating limit as r goes to 0. And this is your LHD. So you can take any arbitrary h, okay, no matter it is negative or positive. So this will be your derivative function. Means that you are calculating the differentiable derivative at any point. You are calculating the differentiability at any point, every point where the function is differentiable, and you are treating it as like a function. Okay?
Yes, sir.
Okay, now what next? Oh, this is the. Okay, you need 5 minutes break. Because I just want to complete it by now, this week 8, so that you will directly start solving the question and all. And slightly you will slowly you will see the question, and the next Sunday's class you will directly told them, sir, please go by example. Otherwise, if I will leave this portion by here, so the thing is that you will not be able to told. So other person who will teach the Sunday's class, they have to complete this all the thing. So you will not have a time to solve the question. Okay. That person will not have that much time to solve the question. So what do you want? Shall I stop here, or like I will move forward after giving you 5-minute break?
Sir, give some examples. We'll try to solve, and by
That's
the
what
end
I'm saying. I have given some example, and what I am saying, either I will give you 5-minute break, and then we'll start the further things like L hospital rule and whatever thing is there. Okay. And in Sunday's class, what you will do, you will ask some example from the your assignment sheet and whatever it has, like practice sheet and all. Because after completing this, you can directly go and start solving the question. And slowly you will watch the lectures. Okay, there you will understand better things better.
So give some
And you
questions.
all.
We'll try
Sorry.
to solve. By then you will come back.
In 5 minutes.
Yeah.
It's for just refreshing your thing, because I am also feeling.
Yes, sir. We will take a
low.
break and reconvene.
Okay, we will take 5 minutes break. and then we'll continue further. And in Sunday's class, you will ask them to solve the question. Ask them to solve the question. If I will take the class, I will start picking the question from the practice sheet, and then we will try to solve the question. Okay, 5 minute break is there. Okay, let's start now. Shall we start?
Yes, sir.
Okay, so derivative function is done. Okay, so here are some just a minute. Screen visible to all, right?
Yes, sir.
Here I have pasted some rule. Just read it. Okay, some useful rules regarding the continuity of a function at a point, and a similar thing will happen for the differentiability function. Okay, so first rule is saying if your function f, okay, if your function f is if your function f is continuous at a and g is continuous at a, then your function f plus g is continuous at a. Okay, this kind of thing is happen. Similarly, for difference thing, if you will multiply some c constant by a function, it will also be continuous at that point. Similarly, for difference that I have seen here. Similarly, if you will see for multiplication case, it will be continuous only. Okay, for if you will divide and this gx is not equal to 0. Otherwise, if it is equal to 0, this fx by gx will not define, right? Right? Basically,
Yes, sir.
I am audible, right?
Yeah, yes, sir.
So basically, these are some small rules. I think you can easily read and then see what is it. Okay, no rocket science is here. Okay, this will help you to compute your continuity thing and differentiability thing. So just look at this. I will explain this sandwich thing. What is it basically? So do you have seen this sandwich thing in the limit part?
Yes, sir.
Yes, sir.
So you have idea about it, right? What's that?
Yes, sir.
So shall I move forward or I will explain this one as well?
I think it's the same, right, sir?
Yeah,
So
it's same.
Oh,
Yeah, instead of this L here, for this case, you will say f of a and all.
yeah.
Okay. So this is same. Yeah, you can do. One more thing that I have to paste here. Just a minute. You can easily find in book this all the thing you can easily find in the book. So before starting the L hospital thing, I will explain the tangent thing and then linear line approximation. Okay. Then you will easily relate why this tangent is going on, and according to that you can relate the L hospital rule. You just give me a minute. Okay, this is one another thing that you have for the differential function case also. If you have function fx and gx and both are differentiable at a point, then your function f plus g is also differentiable at that point. And how will you calculate that? You will calculate f plus g. You will calculate this f plus g prime at a is equals to f prime a plus g prime a. Similarly, for this multiplication, scalar multiplication case, and for this one case, main is this. This rule is main. So the product rule is saying if your f and g both are differentiable at a point. This is just kind of formula. Just remember it. From where it is coming, right now you are not able to see, or you can go by this way. But we don't need to do this kind of stuff. Okay, this proof we don't need. We just need to remember this formula. So this is basically f of g, two function multiplication. You want to calculate this derivative. So if you have this f prime a and g prime a, then you can easily calculate this derivative. This is what first function, then second differentiation of second function, then plus second function differentiability of first function. Okay, or someone will say take second function and take derivative of first function, plus then take first function and then derivative of second function. Okay. Okay. In the last of the class, I will share this kind of thing. So just go through this whatever formula that you have. One more formula that you have. This thing you can easily find in your book. Okay, just a minute. I will paste another one. Quotient rule. Again, I am saying, please don't skip the video, that video, the professor's lecture video. Just go and watch all the things. They have explained in a nice way. Okay. This is one of the things known as quotient formula. If you have a function like this, f and g both are differentiable, then what about this f by g? This will be differentiable, and then this will be look like this. Firstly, first function, the numerator function, derivative of numerator function. Here order will not be changed. Okay, So denominator function, then differentiation of numerator function minus numerator function and differentiation of numerator function and divided by difference like g of a whole square. Similarly, chain rule is there. Chain rule is saying if you have a composition like this, and if you want to calculate f prime g of a, then what you will do? Firstly, calculate the f prime g of x, then again take g of x. This is known as chain rule. So these are the things that you can easily see, not so tough, or just directly go and see. Now from here we will start tangent line and all. Okay, after that, let me see what are the things that after the quotient rule. Yeah, intermediate value theorem is also there. And then L'Hospital rule. Okay. Are you still awake or you guys are feeling sleepy?
Very
Yes, sir.
sleepy.
Very sleepy.
It's almost
I'm also
midnight here.
feeling. Sorry?
It's almost midnight here.
Yeah, I think in the morning 7 class is not good, right? 7 o'clock class. It's not good. At least it has to be start by 9. So that a person like me who slept at 2 or at 3, he will get more time to sleep. Right? I am not talking about your class only.
Yes,
Like
sir.
in my class is also starting at morning 8 o'clock. It's just like worst day for my entire week, especially Monday and then this Friday. What to say? Worst day in my whole week. Like I have to woke up early in the morning at say 6:30 or 7, and then somehow like in hurry I have to just clean up myself, and then I have to go for breakfast and then go for the class. An entire class I was sleepy. So sometimes I will miss the class, but I am not going to say you will miss the class because it is very necessary for you. Somehow we are managing the grades, but it's very important for you because this is your first semester. Because when I was in first semester, I was like that. I was attending each and every classes and all. And after that, we were like, I'm not getting anything in the class. So it's better don't go to the class. Now IITM is introducing an nice system. For that, you have to attend each and every class. Otherwise, they will not going to allow you to sit in the exam. Okay.
Yes, sir.
So this is the thing. Okay. So can someone tell me what do you have, what kind of knowledge you guys have for the tangent line and all? Huh?
So tangent to a curve defines the instantaneous direction of the curve at a particular point.
Yes. Apart from that, if you have a curve like this is not looking like a curve, like this, and I need to calculate my tangent line from this point P. This is what?
Just the grade slope of the.
I will draw a line like this, and then I will calculate this angle. M is equals to tan theta. Right? This is the idea.
Yes.
Whenever I want to calculate tangent line, so-called tangent line, so someone will say, sir, instantaneous direction of on that point. Other will say Other will say, sir, what you will do, you can just draw a line like which is just touching to that point and then see the slope of that line. That will give you the tangent of that particular graph at a point P. Okay, so here we will see how this tangent will be related to our derivative things. How this tangent thing, see, earlier I have told you before in the like week 5 or week 6 classes that we will further see that how we can calculate tangent in with the help of differentiability, right? So here that we will see like how we can see this tangent kind of thing with the help of my derivative function. Okay, so this is my motivation to solve this. Now, earlier when we were discussing about tangent of a graph at some point P, this point. So this is I have seen, sir, I will directly draw a line, but the question is that how will I find that line? Will I find that line? This is my question, right? How will I find that line? How many ways to find that line? Can someone please unmute themselves and then let me know how will I find that line? Please. How will I find that line?
Y is equal to mx plus c.
That's
Based
the
on
idea.
the
See,
coordinates at
y
the
is equals
point
to mx plus c is just like you can find any line, any kind of line. But my idea is I need to find this line. This tangent line or whatever it is. This line which is just touching my graph and giving me the tangent. How will I find this line? Any idea?
It should
The
be
line should not
perpendicular to
cut
the
the
normal.
graph. The line should not cut the graph.
It should
Line
not
should
cut the
touch.
graph, but this is also a line. If I will make this line, my graph
Right.
is stopped by this way. This is also
Right.
not cutting the graph.
And it should touch the graph only at one point.
Yeah,
that's the second
it's
point.
true. But how will I get that line?
Perpendicular to the normal, sir.
Perpendicular to the normal. This is also true. But how will I get that normal? Suppose I am a person who don't know about anything. So how will I see this problem? From where I want to get this line? So what I can do? So firstly, my first question is that how will I get a line? Any line? If so, my question is that how can I get a line, equation of line? How can I get a equation of line? Any straight line. So sir, you guys, someone will say from you guys that sir, what you can do if you have a slope of a line and y-intercept, you can directly go by this formula. Y is equals to mx plus c. Right? Someone will say, sir, if you have x and y intercept, say a and b, then you will say, sir, you can go by this formula. With this line here, a and b are x and y intercept respectively. Someone will say, sir, if you have 1 point and m, this slope m, then you can also find the line. If you have 2 points, say x1 y1 and x2 y2, then someone will say, sir, you can find your line by this y1 y minus y2 and is equals to y2 minus y1 divided by x2 minus x1 into x minus x1. So there are several ways to find an equation of line according to my condition, according to the thing that we have. Now my objective is that I need to find a line like this. Okay, so basically I was thinking about it and then I want to see how will I find that line. So my idea is that I will take 2 arbitrary point here and here. These 2 points I can easily get, right? How I can get? Because these points are lying in my graph. So I can get this point and I can easily get this point. Both point I can easily get, right? And since I have 2 points, I can make a line. Right?
Yes, sir.
So what I will see, I will choose to see, I want to make a line like this at point P. But what I am doing here, what is my idea is I will take any arbitrary point in the graph and I will make a line which is passing through that line. I will use this formula. Right? Right? Suppose
Yes.
this P is my x0, y0. And this is my x1, y1. And this is my x2, y2. Okay. Okay. Please answer.
Yes, sir.
Right. Now, what I am saying further, I am saying, sir, why don't you need this x1, y1 extra? You can use this x0, y0 itself, right?
Yes.
Right. So for that x0, y0, what will be my equation of line? This is my x0, y0. x0, y0. And this is my x1, y1. See. So what will be my equation of line? Y minus y0 is equals to what?
y1 minus y0.
y0 minus y1 divided by x0 minus x1, and this is what? X minus x0. This is the thing that we got now. This will become my equation of line, right?
Yes, sir.
Which is passing through these 2 points. Or in a more precise way, I will make this in a more deeper version. Okay, so I will get 2 points. This is not exactly touching, like this line is starting at 2 point. Okay, this suppose your graph is like this. You got the point? What I am saying? Now I fix this x0, y0 because I don't need this x1. I don't need this x2, y2 or x1, y1 here because I already have 1 point P, right? So I can take another point, this P. Okay. Okay.
That means x1 and x0 are equal.
Yeah, I can put this point here.
Yes.
Okay. Again, I will have 2 points, this x0, y0 and x2, y2, and I can make a line. Right? Here you can use x2, y2 if you don't want to confuse. Okay. I've understood up to this. Now I have 2 points and I can easily get a line equation of line. Right? Now, what is my idea? If I will shift this point along this graph to this point, I will get this line, right? This line,
Yes, sir.
This is my another P prime. If I will move this P prime to this P along this graph P, along this graph at P, so I will easily get this line because if I will put here, so my line will draw like this. If I will put here, my line will draw like this. And once I will reach to this point, I can get this line, right, easily.
Yes, sir.
Right? Everyone is understood this point. This is my graph and I need to reach this point P. I am moving like this. Firstly, my equation like this, then my equation is like this, then like this, and then after some time, I will get this line.
Yeah, got it.
Like this. I will move this like and I will get this line. So this is the nice observation, right? I will take 2 arbitrary point x1, y1, and then I will take this x1, y1 towards this. Right?
Yes, sir.
So what is basically we are doing? This is my x1 This is my x naught. So basically, if I will reach, because this function is differentiable that we have taken earlier, okay, function is differentiable. So once my x1 will go toward x naught, because of continuity, already my y1 will go to my y naught, right?
Yes, sir.
Since function is continuous. Right?
Yes,
This
sir.
is what? Y1 is what? F of x1, right? And this is what? F of x naught. Y naught is f of x naught only.
Yes, sir.
Right? Understood up to this? Is there any doubt that you have up to this? Then you can ask. No? Move further. Let's move further. So what I am saying? I am saying if x1 will go to x naught, or you will say in this case x2 will go to x naught, my f of x2 will go to f of x naught, right? Or you can say y1 will go, y2 will go to y naught. So in this case, what happens basically? Y minus y naught. Take limit both sides. So here nothing will happen because here we don't have x2, y2. So here only we have x2. So I am taking here only. So here I am taking x2 goes to x naught. This is my what? F of x naught minus f of x2 divided by x naught minus x2. X minus x. This is what? This is what that we got here. Limit x goes to x naught. F of x naught minus f of x divided by x naught minus fx, or you can say limit x goes to x naught fx. You will multiply minus in the numerator and denominator. You can easily get this. This is what? Derivative of a function at a point x naught, right? Right?
Yes.
Right? So basically I can, and this is what basically, initially this was what? This is your m, right? This was your m, no? In this case, whenever you are calculating the equation of line, whatever this coefficient will give me, this will give me my slope, right? M. Right?
Yes, sir.
My slope tan theta will define like this, no? Tan theta is equal to y2 minus y1 divided by x2 minus x1. That was my point. How will I calculate this? Easy. That what to say? What is the definition of tan theta? It is base, sorry, height by base. From this formula, you can easily get this y2 minus y1 divided by x2 minus x1. So this will be my slope, right? At some point, because here I am taking x2 goes to x naught. So this will be my slope. And this is what? F prime x naught. So from here, what we got? We got that if I want to calculate a tangent or slope, both are same. Tangent or slope at a point, say x naught, and if f is differentiable, here this all the thing we are getting from the differentiability concept only. Differentiable at x naught, then slope at that point, slope at x naught is equals to f prime x naught. Right? From here we got this. Understood up to this? So see how the nice result it is. If you want to calculate a slope at some point, you just differentiate it with respect to that point. And then see the value. Okay? Okay. Now, after doing this, how will I get? I will get y minus y naught is equals to f prime x naught. I am just putting the value and x minus x naught, right? Say something. Then only I can understand now you are getting the point or not.
Yes, sir, it is understandable.
Right? From here, I can easily get this equation of line, right? I got the line f prime x naught, x minus x naught plus y naught is what? F of x naught. So this line is known as tangent line at some point x naught y naught. This line is known as tangent line of f at x is equals to x naught. This line is also this function is also known as linear approximation of a function, given function at a point x naught. Got the idea for both what is tangent line and what is linear approximation of a function at a point? Please answer. Got the idea behind both things?
Yes, sir, got it.
And what will be my tangent for differentiability case? M is equals to tan theta, which is what? Limit x going towards x naught, f of x minus f of x naught divided by x minus x naught, which is what? F prime x naught only. Okay, these are all the things that we have up to this. Okay, let's take some example from where you have to calculate this kind of thing. So what kind of question they will ask? They will give you a function, any arbitrary function, suppose fx is equals to, they will say x square. Okay, and then we will say what is the, okay, or they will say find the linear approximation of fx at x is equals to 2. Then what you will say? You have a formula, the linear approximation. The linear approximation is given by this f prime x naught. Here x naught is what? 2. X minus x naught is 2 plus f of x naught. Okay. You can easily find the value of this f prime 2. Since this is x square quadratic function, you know that if you have a quadratic function ax square plus bx plus c, then how the tangent will look like? The tangent will be 2ax plus b only. Right? So just
Yes, sir.
here, what is the value of a and b? B is equals to 0, a is equals to 1. So what will be the tangent function for this case? 2x only. Just put in this case, this will become your f of f prime x. So just put x equals to 2 here. So f prime 2 is what? 4 only. So here you will just put 4 here, 4, then x minus 2. And what will be f of 2? It will be 4 only. So what you will get? Y is equals to 4x minus 8 plus 4, which is equals to y is equals to 4x minus 4. This will become your linear approximation of given function at some point. Or they will say find the tangent line of that function. So this will become your tangent line as well. So both are same, tangent line and linear approximation. Why we are saying it is linear approximation? Because somehow whatever I am doing this thing by this line, we are approximating this function. We are approximating this red function by this line, right? That is why we are saying this is a linear approximation of a function. And in this case, for the linear approximation case, we will denote this y as L of x. L of x, linear approximation. Okay, so whenever you will use tangent thing, you will use this y. Whenever you will use linear approximation thing, apart from this y, you will use this Lx. Okay, got the idea up to this? If you have some doubt, then you can ask. Just ask. I am waiting for your response. Any doubt, any small doubt, if you have, even if you have a small doubt in this, please ask, because at least one question will be there in quiz 2 from this topic. This linear approximation and tangent line. Or maybe they will ask in the end sem as well. Well, this is very important topic.
So tangent for this line, we will got 4 now. Y is equals to 4.
Yeah, tangent will be
At
4.
yes, sir. At x is equals to 2.
Yes. And tangent line will be given by this 4x minus y is equals to 4x minus 4. Tangent line is different and tangent is different. Tangent line is what? By which line we are getting that tangent. Okay. See
Yes,
here
sir.
in this example, in this red curve example, in this example, I was getting my tangent by this red line, right? So that line, whatever I got there, that equation is for this line. Okay, this line is known as tangent line. That what are the line I am giving from which line I am getting the tangent? That line is known as tangent line. And this line is also known as linear approximation of a function at that same line. Okay, name is different, but okay, just name is different.
Yes, sir.
So
Got it.
this line will be the tangent line.
Yes, sir.
Okay.
We are going for linear approximation to calculate this. We already know the previous methods, sir. Then why we are going for this?
See, here linear approximation thing is nothing but it's just another name of tangent line. Okay, we are using this linear approximation because somehow if I am doing this, I am finding this tangent line. So somehow what we are doing, why we are trying to approximate this line, no? Approximate this line. What does it mean? I have taken one arbitrary point here, and then I will move from here, and then I will take another arbitrary point. Then I will move this. So somehow we are approximating, we are reaching toward this point. It means that what? We are approximating my function, right? We are moving towards function. So we are approximating my function by this linear line, right? Firstly, my line was there, then this, right? Right? So if I will get this line for each point, suppose this is my function, this is my function. Okay, if I will get this tangent line for each line, so this will look like this, and this. I don't know how you are getting my point or not. Let me use GeoGebra for that. If I am able to use.
Sir, can you give another example?
Just a minute. I'm trying to use GeoGebra so that you can easily get what is my point. Okay, this is the last topic, and after that we have only two things. What L-hospital rule that we have already discussed in the Sunday's class, I guess. But now we have to just frame it.
Sir?
Yes.
Sir, I didn't understood the difference between tangent and tangent line.
Tangent is just a line which is giving me the tangent.
Both are same.
Yeah, both are same. Tangent is the tangent line. Here, there we are using line word. Now it means that this will give me the equation of line. Tangent is what? Tangent is what? Slope of that line.
Okay.
Okay.
The slope is what giving the direction. So it is the tangent and The line is the tangent equation.
Yeah, how will I explain? Just a minute, okay? See this graph x square. Now, if I will calculate my tangent here. Here I did. Okay. So if I will calculate my tangent here, the tangent will be look like this. If I will calculate my tangent here, the okay. At 0, it will be look like this. If I will calculate my tangent here, so it will be look like this, right? It will be look like this. Now, if I will calculate my tangent here, how will it look like? It look like this, right? This is my tangent line.
Yeah.
There are infinitely many tangents will be there for this, right? sir?
Yeah, but what I am trying to say, basically, this will be my tangent line. Now, if I will calculate my tangent line here, so this will be my tangent line. So what we are trying to see here. So basically, as I am getting my tangent thing, I am basically approximating my function, right? By these lines. Once I got all the lines, once I got all the lines, and if I will try to make if I will try to form by this point kind of thing, I will get this line, right? I will get this graph of the function, right? This thing. So what we are doing basically, see.
Sir, we are making
What?
from graph itself, no, sir. Then why we are going for up?
See, suppose we have, firstly we have a point. We are making a graph itself, but what we are doing, I am approximating this graph by this line now. Initially, if I want to calculate here, so initially my line was there. I want to calculate in this point. Just this point, I have to calculate the slope. Okay. Now what I will do, I will choose this point and then I will make this line. Then I will choose this point. This is the line.
You will
One
approximate.
another.
Yeah, got it.
So what this was my original point. Now I am going like this. So are you able to see or not? As you can see, let's zoom out. And then firstly, I took suppose I took this point. Then I got another equation of line. Then I move forward and I took this point. Then I got another equation of line. Then I put this point. Then I got another equation of line. Then I got this point. I got another. Once I will reach here. Once I will reach at this point, see. I will reach this point. I will get the tangent line, right? So what we are doing basically, from here to here, I am going with my function only now. Whatever point I am choosing in my function only. Just see the cursor. I am choosing my function only, right?
Yes.
Right? So basically what we are doing, we are approximating my function by this line only, right? At this point. Right?
Yes, sir.
Okay, so that is why this line is known as either, since this will give me my tangent, so I will say this is my tangent line. Another reason is that since this somehow this is approximating my function in a linear function, then we will say this is a linear approximation. When you will learn this, once you will learn this Taylor series concept, I don't think so you guys have seen or not. Then you from here you can see any differentiable or any continuous function can be approximated by a series, and first two term is given by this only, this thing only. Okay, this is about your course, so forget about it. But yeah, this is the thing. Okay.
Okay, sir.
I hope you got the idea.
Yes.
Okay, so this is what we have, tangent line and the linear approximation of a function. So you got, if they will give you any function, then you can easily find the linear approximation of the function, right?
Yes, sir.
You have the nice formula to get this. Now after that, let's move toward L'Hospital thing. What is my LH rule? So in the Sunday's class, I have seen that if I have this function x square minus 4 divided by x minus 2, and I need to calculate limit at x equals to x tends to 2. What we will see, this will be the case of 0 by 0, right?
Yes, sir, but factorization.
Yes. So how will I see after that? I will see how fast this function moving towards 0. Or how fast this function moving towards some point. What is the growth of this function? Right, that thing we will see. Just like an example of e raised to the power x divided by n. X. This is also going towards infinity. This is also going towards infinity. Now what I will see? I will see how fast this function goes towards infinity. Or if I have a function like this, suppose I have n divided by e raised to the power n. Here, this function go towards infinity, this function go towards infinity. Now I need to see where this entire function will go.
Yes, sir.
Right, this is my idea. So the thing is that I will see that which function is going towards infinity in a more faster way. Right? So as you can see here, this e raised to the power n, this e raised to the power n function will going towards more faster than this n, right? This will reach to infinity before than this n, right?
Yes, sir.
Right? So what does it mean? Before this n, it means that the speed of this function by moving towards infinity is higher than the speed of this function, right?
Yes, sir.
And what we have seen, it means that this will dominate my function.
Yes, sir.
Right? It means that this whole thing will become 0 because this will reach towards infinity before this point.
Yes, sir.
So how will we see? So we will see. So the L'Hospital rule is saying, if function is differentiable, then limit x goes towards some x naught, fx divided by gx is same as limit x goes to x naught, f prime x divided by g prime x. Okay, if the case is like 0, 0, infinity by infinity. If these two cases will happen, then we will say like this. Or 0 by infinity and infinity by 0 as well. If we will get some intermediate form, then we can directly calculate by this way. Okay. In this case also, suppose I need to calculate limit x goes to 0 or x goes to infinity at x by e raised to the power x. Now what can I say? What will be the differentiation of this function? It will be 1 only. Slope of this tangent line. Further you will let you know how will I calculate this. Okay, I will share you some formula from which you can directly calculate the differentiability thing. And here you will get e raised to the power, then limit x goes to infinity, this whole thing, this will be goes to 0, sorry, infinity, this whole thing will go to what?
0.
0.
0.
Okay, so this is the L'Hospital rule. Okay.
Yes, sir.
Now, last thing is intermediate value theorem. Then after that, I will just give you some
Sir,
formula. Yes. Yes.
sir, why 1 power infinity is undefined?
Infinity is undefined because infinity is not a real number, right?
But 1 power anything is 1 itself.
Sorry.
But 1
Sorry.
power anything is 1 itself.
Okay. So this 1 raised to the power x is equals to 1 whenever x belongs to R. Okay.
Yeah.
But infinity is not inside R. Okay. This will happen only when you will take this x from your real number set. But infinity is not your real number. Okay.
Okay. Sometimes we assume.
Then 1 power infinity is infinity, sir.
So we cannot say anything about it.
No.
Because we don't know about the infinity.
Sometimes infinity we assume as a very large number. Then that
We will not assume infinity as very large number. Okay. We will take a sequence which is which will be diverse towards infinity. I will take a sequence of number which will go towards infinity. It will look like it will go towards infinity. Then we will approximate this value. If someone will say what will be the limit x goes towards infinity 1 raised to the power x, it will be 1. But we cannot say 1 raised to the power infinity is equals to 1. Both are different things. This is not equal to each other. Both are different. This is not defined.
Okay.
Okay, and this is defined. Why? Because I am taking whenever x to grows x approach towards infinity. It means that if I will take x larger and larger, where this 1 raised to the power x will go. So whatever I will, you will take 10 raised to the power 1,000, billion, trillion, whatever you will, so it will be 1 only. So thus this sequence will converge to 1 only. Means that whenever x will go towards infinity, this 1 raised to the power x will converge to 1 only. Okay, it does not mean that it is 1. Because continuity thing will come into the picture after that, no? This is what? F of infinity, no? But this is not defined because infinity not a real number. Okay, let's move towards intermediate value theorem. So what does it mean? This theorem is saying if you have two points, if you have an interval AB, okay, and your function is differentiable in this continuous in this closed interval AB and differentiable in this open interval AB. Okay, because for differentiability, I don't need to check. For generalize this thing, I don't need to check in this the outer point. Okay, I need to check only the inner points. What are the points are there in this point? And if you will see that, yeah, your f of A and f of B are equal to each other. What does it mean? Your graph, whatever graph it will be, the f of A thing and f of B lie in the same line, which is parallel to the x-axis, right? So the theorem is saying that there will exist a point A, C in this point. There exists C in this open interval AB for which the derivative of this function will be 0. It means the slope will be 0 at that point. So suppose you just, okay, so it means that there will be point here. For this case, this is the point where the function is 0. So the derivative function is 0. It means the slope is 0. What does it mean? Suppose you have 2 point this same in the same these 2 point lying in the same line, right? Okay.
Yes.
Now if you have a wire kind of thing, so take a wire, take a copper wire. Okay, this is my copper wire, and try to bend and put both corner, this corner to this point and this corner to this point. Your copper wire will look like this, no? Right?
Yes.
Then you will always get some point which is parallel to x-axis. The slope of that point will be parallel to the x-axis, right? Here you will get slope f prime something c naught will be 0. Here you will get at least 1 point you will get, right?
Yes, sir.
Right? Because for the differentiable function, the function is moving towards this and it has to be reached this point. There always exists a 1 point for which the slope will be 0 and then it will start decreasing. That kind of thing, right?
Yes, sir.
Right? So this thing is known as intermediate value theorem. What is it saying? If your f is continuous at AB, differentiable, close interval, okay, differentiable at this, and f of A is equals to f of B, then there exists and C belongs to this AB such that f prime C is equals to 0. Means the slope at that point will be 0. Okay?
Yes, sir. Got it.
Okay, so shall I? So you want this PDF?
Yes, sir.
Pasting this. Okay, so please go and watch the videos also. Also go and try to solve the practice assignment thing.
Sir, where to find
So
the
that who,
PDFs?
sorry?
The PDFs notes.
Yeah, I'm saying
No, sir, where to find it?
here itself. I will send through the chat box only.
Okay, sir.
From where we can paste. I am not able to find any. Earlier we were able to paste our from here we can paste our screen. Send it, okay? It will go by fraction. Okay. I have sent to everyone.
Got it, sir.
Okay, please download it. Okay. Okay, bye guys. Have a nice day. Please start solving the question.
Okay, sir. Thank you very much.
Mm.